So what does it mean that a compound is soluble in water? What happens when a compound is dissolved in water? Let's use sodium chloride for example. Sodium chloride is table salt, and if you were to pour table salt in water, the table salt would appear to disappear. It would dissolve in the water. You won't see it anymore. You'll just have one clear solution. But what's actually happening? In sodium chloride, you have positive sodium cations and negative chloride ions attached to each other. And so you got this big solid that's composed of ions. And once you place this ionic crystal in water, the water molecules are going to pull apart this crystal. Water is polar. The oxygen part of water has a partial negative charge, and the hydrogen part is partially positive. Overall, water is electrically neutral, but oxygen is more electronegative than hydrogen, so it pulls the electrons toward itself. Thus, oxygen has a partial negative charge, and hydrogen is partially positive. Due to this partial charge of the elements in water, that makes water polar. And a lot of salts, like sodium chloride and other compounds, they tend to dissolve in polar solvents. So the oxygen part of water is attracted to sodium. And we can see why opposites attract. Sodium has a positive charge, oxygen has a partial negative charge. The hydrogen part of water, which has a partial positive charge, that's attracted to the negatively charged chlorine atom. And so what happens is that all of these water molecules are slowly pulling each ion in the crystal away from each other. So the oxygen is pulling away the sodium ions, and the hydrogen atoms are pulling away the chloride ions. So eventually, these ions move apart, and they're more attracted to water than themselves, and that's why sodium chloride dissolves in water. The sodium chloride ions, they have a greater affinity for water than they do with themselves. And so water pulls it apart, and then it dissolves. So once all of the sodium cations and chloride anions, once they're all pulled apart, this is the situation that we now have. Each sodium ion, keep in mind a cation is simply a positively charged ion. Each cation is surrounded by water molecules. Notice that the oxygen part of water is facing sodium. Remember, opposites attract. Oxygen has that partial negative charge, and so it's attracted to the positively charged sodium cation. So at this point, the sodium ion is dissolved in water. It's surrounded by water molecules. And the chloride anion, anions have negative charges. They're surrounded by the hydrogen atoms of water. Now, as was mentioned before, the hydrogen atoms contain a partial positive charge, and so it's attracted to the negatively charged chloride ion. And so the water, it basically stabilizes it. And so that's a situation that happens when sodium chloride dissolves in water. But let me give you a picture. So let's say we have a beaker, and we have water in it, and let's say we're going to put a crystal of sodium chloride. So before it dissolves, you have all of the sodium and chloride ions together. So the positively charged ions are the sodium ions, and the negatively charged ions are the chloride ions. And as soon as this crystal hits water, water is going to try to pull it apart. So the oxygen part of water pulls away the sodium ions, and the hydrogen part of water pulls away the chloride ions. So in time, all of these ions will be dissolved. They will be separated from each other. So we're still going to have the same number of ions. As you can see, water just pulls all of them apart. So all of the sodium ions are now separate from each other, and all of the chloride ions are separate from each other. I think I have an additional circle, but you get the picture. So that's what happens when an ionic compound dissolves in water. The crystal breaks apart and it separates into positive and negatively charged ions. So when you have a saltwater solution, because you have ions in a solution, this solution is electrically conductive. You can conduct electricity. So let's say, for example, if you mix sodium chloride with water, and if you take 2 copper electrodes, it could be 2 zinc electrodes, really doesn't matter, but let's use 2 copper electrodes. And if you connect it to a 9-volt battery, which is also in series with a light bulb, you'll see that the light bulb is going to light up. It's going to be very bright. So the more salt that you add, the greater the conductivity will be. So the light bulb is going to be bright. But if you try to use pure water, it's not going to light up. If you use tap water, there might be some dissolved ions in it, so it's probably going to be dim. But as you add sodium chloride to it, you should see the light bulb getting brighter and brighter. Because a solution of sodium chloride conducts electricity, it is known as an electrolyte. Now, because it conducts electricity very well, it is a strong electrolyte. Any ionic compound that is soluble is a strong electrolyte. It ionizes completely. You could say the ionization is almost 100%. So for every 100 molecules or 100 formula units of sodium chloride, you're going to have 100 sodium ions and 100 chloride ions. Strong acids are also strong electrolytes. They conduct electricity very well. Weak electrolytes, they only partially conduct electricity. The light bulb will be very dim. So let's say if you dissolve a weak acid, like acetic acid. Acetic acid doesn't dissolve very well. It's found in vinegar. It ionizes a little, maybe about 1%. So the light bulb is going to light up a little, but it's going to be very dim. And that is a good indication that you have a weak electrolyte in a solution. Now, there are other substances that dissolve in a solution but do not conduct electricity. For example, glucose and sucrose. Sucrose is table sugar. Sucrose is C12H22O11. So sucrose, it's polar. It dissolves in water, like dissolves like. Polar compounds dissolve in polar solvents. However, sucrose doesn't ionize the same way as sodium chloride does. Now the situation is very similar. You have a lot of sucrose molecules when you place sugar in water. And when it dissolves, these molecules separate from each other. Now, this one circle doesn't represent an individual atom. It represents this entire molecule, which has many atoms. So the atoms are not breaking apart. what's happening is that one sugar molecule separates from another sugar molecule. You see, in this crystal form, all the sugar molecules are attached to each other. But when it dissolves, those molecules, they pull apart from each other. But each molecule has 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Water does not separate the atoms inside the molecule of a sugar, or of a sugar molecule. It separates the sugar molecules from each other, but not the atoms within the sugar molecule. So keep that in mind. So sugar doesn't ionize. If you try to pass electricity through it, and if you try to see if the light bulb is going to light up, it won't. So therefore, it's a non-electrolyte. It dissolves in water, but it doesn't ionize. It does not conduct electricity. If there's no free-flowing ions in water, water will not conduct electricity. Now, before we conclude this video, there are some other terms that you need to be familiar with. What is the difference between the words solute, solvent, and solution? What do these words mean? So let's say if we dissolve sodium chloride, table salt, in water, which one is the solute, which one is the solvent, and which one is the solution? Sodium chloride, aka table salt, is the solute. Water is the solvent. The solvent dissolves the solute. Water dissolves sodium chloride. It separates it into sodium and chloride ions. The solution is the combination of the solute plus the solvent. So the salt-water solution. The salt and the water combined makes up the solution. Water by itself is the solvent. Sodium chloride by itself is the solute. So if I were to mix, let's say, 2 grams of sodium chloride with 98 grams of water, I will have 100 grams of solution. So keep this in mind. In terms of mass, the solute plus the solvent is equal to the solution. So let's say if I have 300 grams of solution and 5 grams of sodium chloride, I can figure out how much water is in the solution. So that would mean that I have 295 grams of water, because it has to add up to 300. And so there's a mathematical relationship between the solute, solvent, and the solution. So if you ever get confused about this, just keep this in mind. Water is a solvent, sodium chloride is a solute. So the solvent dissolves the solute. The solute is dissolved by the solvent. By the way, perhaps you heard of the term aqueous solution. What does that mean? What does the word aqueous mean? If you ever see that in your chemistry textbook, it's very simple. An aqueous solution is basically a solution in which the solvent is water. Because sometimes the solvent could be something else. It could be ethanol, it could be alcohol, it can be methanol, it can be a lot of other things. But when water is a solvent, the solution is called an aqueous solution. So now you know what this term means if you ever see it again, which I'm pretty sure you will. Now let's say if you want to increase the rate at which sodium chloride dissolves in water. How can we do so? One of the most effective ways to accomplish this is to increase the temperature. If you increase the temperature, 2 things could happen. The first thing is the rate of dissolution, the rate at which sodium chloride dissolves, will increase. In addition to that, the solubility will increase. That is the maximum amount that the solution can hold at any given temperature. That's going to go up. So you can dissolve more at a higher temperature, and at the same time, the rate at which the solid dissolves in water will increase as well. Now, if you increase the surface area, let's say if you ground a cube of sodium chloride into a powder. If you increase the surface area by pulverizing it into a powder, the rate of dissolution will increase. It will not affect the solubility. The amount that the solution could hold at that temperature will be the same. Solubility is directly affected by temperature, but you can increase the rate at which something dissolves if you crush it into a powder and then put it in water. But if you put not an ice cube, but a cube of sodium chloride in water, it's going to take time to dissolve because there's not as much surface area. So if you can increase the surface area, if you can increase the area at which sodium chloride is in contact with the solution, then you can increase the rate at which it dissolves. So those are some things just to keep in mind when dealing with solutions and solubility.